Hello, welcome to another edition of Data in the Hallway. Good to welcome back Ahmad Ghazal, one of our distinguished engineers for TiDB. Ahmad, this is the third time you're appearing, so I think you should win some sort of a prize, like the most appearances on a podcast. I think the first topic was on benchmark, and then I think last year we talked about TiDB Index Advisor. So somewhat related topic. Wanted to celebrate and talk about one of the papers that got accepted by the IEEE, which is not an easy thing to do. The title, I'm going to read it off the paper, Hyper. It says Hybrid Physical Design Advisor with Multi-Agent Reinforcement Learning. It rolls off the tongue. But yeah, somewhat related to the previous topics on indices and index advisors. But yeah, so yeah, first of all, yeah, talk to us about what Hyper is and what challenges that you're trying to address with this research.
Sure. So yeah, this paper is was a collaboration between us at TiDB and academia. So this was a successful collaboration from that perspective. And yeah, and as you said, this is kind of a related topic to the index advisor. So within the space of recommendations about physical database design. And the problem here, it's kind of an extension of what the index advisor was trying to do by looking also at the bigger scope kind of problem, which looks at the index recommendations and columnar recommendations, which really fits well for the HTAB systems, these modern databases that try to address transaction systems or TP or analytics, OLAP. So this is the tool trying to address that because there is some interaction, either competition or coexistence between these decisions. So it's trying to address the bigger scope in terms of the recommendations here, more than the index advisor. Yeah.
Yeah, I think like what traditional like index advisors, when we talk about things, is mostly focused on like row-based traditional databases. But like you're saying, for like HTAP or analytic capabilities, you also need to look at like a column-based like use cases. And I would assume, I mean, you're obviously looking at like a multiple angles, and the problems would be more complex. But uh, beyond just going beyond looking at also column based like databases or use cases, so what makes this use case more complex? Like, are there is I assume there's more than just row versus column based approaches, but what are some of the other factors that contribute to the complexity of this issue? Uh,
Sure. So usually, yeah, when you try to solve this problem, you solve it for real life complex workloads that includes hundreds, thousands, sometimes hundreds of thousands of queries. And also you may have, a huge number of tables, schemas. And actually in TiDB recently, we've been we're solving these million table schemas. So we have that huge combinations of schema size, workload size, and trying to come up with a physical database design choices that fits this overall picture is very complex. So from a human perspective, this is becoming almost infeasible to actually go through all the queries and try to come up with a whether it's an index recommendation or it's a the optional columnar or no columnar for those. And so it's really a search space problem, like other search space problems we deal with in the database. But the number of combination is huge. because there is a some kind of competition between the row-based index recommendations and columnar. Sometimes if the query is complex, you don't need an index, and you need a columnar. Sometimes you need an index, sometimes you need both. So the search space here is really complex, and this is one of the challenges this tool is trying to solve. Um, in addition to that, the most of these tools they do what's called what if scenario. In general, you have a large search space, you need an intelligent tool that actually control that search space and use heuristics to cut down that search space. And then it will do what if scenarios for that smaller, more intelligent, promising search space. So we do have an issue with the what if scenario accuracy. So this tool is also addressing that angle as well, improving the what if scenario estimates, more than previous work.
Okay. Yeah. So I think like I'm guessing like the last point is probably related to more accurate like evaluation. I would I, that's I guess how I would think about it. And then I mean like you said, like you have a huge you know instead of just looking at like a row based like indices for example, you have a much larger scope you're dealing with, I guess. And then I would assume there would be some like interactions between like a uh, 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 like a two different scenarios as well between row based and column based. So yeah, I would definitely assume it becomes a lot more complicated problem that people will have to deal with. So, I mean, maybe this is a dumb question, but is hyper like is it fair to think of this as a sort of a framework or approaches to finding ways to do like a queries faster and quicker? Or I'm not sure if the framework's the right word, or is this like a different approach to getting to faster queries? But
Yeah, so in essence, it's similar to the index advisor we talked
mhm,
about in the past.
mhm.
So it's a physical database design advisor
Okay.
that gives a recommendation to the user of having which indices to create and which uh, uh, like in the TiDB, we call TiFlash, this columnar replicas, which are optional. So it gives it addresses these two problems together. The user can review the recommendations and apply them, but it's really, in the industry, they call them, design advisors or design wizards. So this is in
Mhm.
that scope.
Okay. Okay. Cool. Yeah. Thanks for clarification on this. And then, I mean, obviously, to be honest, I tried to read the paper, but it's quite dense. I'll have a link to the paper. I mean, a lot of the sections I have to sort of skim through it with lots of formulas and et cetera, et cetera. But I don't think everybody, like every developer sort of needs to understand like every aspect of the paper. I mean, it would be great if you do, but I don't think that's necessary to sort of understand like the challenges that you talked about and what hyper is. Um, and I couldn't help myself as I was sort of scanning through the paper. You talk about like AI and ML and sort of how they help and obviously machine learning and AI is a very popular topic. So how does like AI and ML help, or how did it help in your research and providing guidance to the database design?
Yeah, this is a great question and really an interesting uh, problem these days. So AI, from our perspective, there is data for AI and there's AI for data. So data for AI, that's what we are trying to do in TiDB and many other databases where we provide some AI infrastructure that people can do their own AI. The other one is we're leveraging AI to solve database problems, which is exactly what we're trying to do here. So in this case, we are in the AI for data space here. And we are leveraging AI for this physical database design problem, or this design wizard or design advisor, you want to call it that way. And in the AI literature, they have what's called reinforced learning. So reinforced learning means that you start with a solution and you iteratively come up with better solutions based on a reward function. So the reward function is the one that makes an assessment of your solution, some ranking function or something like that. And so we have leveraged this reinforced learning. So that's one problem in AI. The other problem is multi-agent, and the multi-agent means that you have different AI components trying to come up with a solution. So we have one for the row-based and we have one for the column-based. That's why it's called multi-agents. We have two agents. So it's a combination of reinforced learning and multi-agents, and the multi-agents, each one come up with a recommendation for each problem separately for the indices and for the columnar. And then the combination is being evaluated. And then these two agents will collaborate on coming up with the best solution because of the interaction between the two. And eventually, the two is going to converge into a global unified solution of both problems. So that's in a very high level how this works.
Cool. Awesome. Yeah. Yeah. That's a like a term I don't think I've heard before, like an AI for DB. But I think like all software developers, I mean, you're using AI to like you said, reinforce learning and then to improve your software. In our case, the TiDB database itself. Um, and I think like one of the features, I mean, not that I've read a ton of academic papers, but I mean, maybe it's not just for academic papers either. When you're talking about a specific technology or feature, you have to sort of demonstrate that why this works and why this is sort of beneficial. And there's a section in the paper that sort of goes through that. But can you walk us through like how you're able to demonstrate this that Hyper is going to help you know build better database designs. So,
Yeah, sure. So yeah, a
yeah.
big effort in this work was the verification or evaluation of Hyper. And so we run this tool, this approach on many standard known benchmarks, and those benchmarks include the transaction system like TPCC and or the OLAP like TPCH and TPCDS and other benchmarks. We also run it on the kind of hybrid workloads that they are trying to simulate HTAP system. We didn't run it on Web3 bench that we talked about way back, but we run it on comparable benchmarks that have this mixed workload. So so we try to run it on these different types of benchmarks, and the evaluation measures two things: measures how much performance improvement was done with and without the recommendations, and how long it took for Hyper to come up with a solution. So, and both aspects, the results were excellent. In the benchmarks, we got average about 20% improvement on either on the OLTP or OLAP. We got about 40% on the mixed workloads. In the training, this is known in AI to be an expensive thing. So Hyper ran from 30 minutes to 200 minutes to do the full training on these benchmarks, which sounds maybe high, but it's quite acceptable because the training is done once, right? So if you have a real customer scenario, a real customer that will use this tool, they're gonna spend less than an hour. Um, and sorry, I mean 200 is like what, 3 hours or something like that. Yeah, a couple
Yep.
of hours. Yeah, a
Yep.
couple of hours, which is feasible and which is
Mhm.
doable. So they spend a couple of hours to do the training, and they get a physical database design, which they don't have to run daily or even weekly. So this is overall the training time, and the performance improvement were excellent, and it shows the value of Hyper.
Cool. Yeah. I mean, there's I think section called like evaluation. People can get a lot of details on like which
Yeah,
versions of TiDB that were used and the hardware setup and all that. But with lots of charts too, so people will be able to see pretty clearly a lot of the benefits that you just talked about. And I think this is like, I mean, I think you sort of mentioned this already. Like, I don't think hyper is something you're going to see. Like, it's not going to be like a button in TiDB when you use the software. Like, I assume a lot of this is what you talk about in terms of hyper is already being integrated into TiDB. Like, you're not going to see. I don't think we'll see like a campaign to sort of to see hyper. But I mean, the question was, when are we going to see hyper in TiDB? But it looks like it's already being integrated into our open source software. Just yeah, I mean, go ahead, Ahmad. Like if you want to add on to that.
yeah. So yeah, right now it's in the prototype mode, and it's really a generic solution, but was verified and shown for TiDB, but it's a very generic solution. And we have plans in the future to be this in production. So right now we're just in the prototype uh, vision. We also need to see how we're gonna integrate this with the index advisor, or this is
Mhm.
gonna be a superset of that.
Right, right.
Yeah,
Cool. Yeah, I guess as we, plans firm up, I mean, I'm sure there'll be blog posts and like discussions on this, and maybe we'll have you back on once it's fully in production. So
absolutely.
cool. Yeah. Yeah. So yeah, I mean, thanks for giving us an overview. I don't think a lot of us in the industry get a chance to read academic papers. But I mean, congratulations. I mean, this is not like IEEE is a pretty renowned research organization. It's been around for obviously decades. But wanted to ask, I mean, like at a high level, obviously academic research paper is very different from like industry papers, right? So wanted to sort of ask, what are some of the processes that are involved in, things like, beyond doing research, like what are some of the processes that are involved in getting something published with IEEE? And for this paper in particular, like how much time did you invest along with our academic partners on getting this published?
Okay, yeah, very, very good question. Yeah, so yeah, ICDE is a top tier conference. So in databases, there are three top tier conferences, and ICDE is one of them. And usually acceptance rate is around 15% to
Mm,
20%. So it's very competitive. I mean, we usually at TiDB try to go to these conferences and submit papers in the industrial track if we are leading those. At the same time, we also collaborate with universities that they take the lead on publishing research papers. So this is a very nice collaboration where we try to, from the industry perspective, we try to strengthen the motivation, the real life use cases, provide the platform for evaluations, and also check how the practicality of those solutions, would they fit in a commercial systems or not. So from the research perspective, you have to have a good motivation for the problem. You have to have an important problem. Like here, we do have an important problem for this physical database design. and then there should be some novelty. So novelty is a key point for research papers, which is also required in industrial track papers, but it's more required or more emphasized in the research track. So a novelty here is the using of AI, this multi-agent reinforced learning. And then the third component is really a strong evaluation, which is where this is our part, the TiDB part was very crucial in that.
Cool, awesome. Yeah, I mean, again, congratulations. It sounds just, or if not more competitive, um, compared to like getting talks accepted like open source or industry conferences. But I mean, kudos. And yeah, I mean, it's also nice to collaborate with people in academia. I think that's something that's obviously very, very nice to see. Talk about people. I mean, talk to people that are doing research that are looking, like a decade down the road. So, yeah, congratulations. This is like one of two papers that was recently like accepted from with TiDB members and IEEE. So, yeah, I'll probably add a link to the other paper as well for people to take a look at some of the research activities that we've been involved in. So yeah, so thanks again, Ahmad. Like I said, this you've been here like three times, and it's always like great to have you. And thanks again, and I'm sure we'll have you again again in future episodes as well. So thanks.
Absolutely. Thank you,
Yeah,
Ray. This was
yeah,
fun. Thank
right.
you.
Thanks.